Hello everyone, welcome to Tech with Machines. Today's topic is going to be another array problem, and it is going to be quite similar to our previous problem, remove elements. If you haven't yet seen that video, you can go to the playlist of data structure and algorithms and watch that out. It is quite similar to that problem because we are going to use two-pointer technique, as the array is sorted and we are supposed to remove all the duplicates from that array. Basically, we are only supposed to keep one occurrence of each element if it's repeating itself. Like in this case, we have a array called nums, and we are given a 1 which is existing twice, and then there is 2 which is existing only once. So 1 is duplicate, so we are going to only keep one occurrence of number 1, and we will after that will remain with the length of the new array as 2. It is quite similar to the previous example where we have been given an extra space in the array itself, and we have been given basically we are not supposed to create a new array. Instead, we are supposed to give the expected length of the new array by giving the position, last position, after which we would have moved duplicates to, right? After which we would have moved duplicates actually. So as you can, if you remember the previous problem, we used two-pointer technique, and in this also we are going to use two-pointer technique. Before I go ahead and try to dry run this particular problem, I would like to clarify that I'm not really spending time on explaining brute force approaches here, and directly moving to optimal solutions and the techniques or the patterns. I'm highlighting more about the techniques and the patterns which are correlated, which you can correlate with any problem while you're solving. If you would like me to basically have a brute force approach as well, please do comment, and I would really be happy in actually logging that as well. So let's start with today's problem, and if you don't remember, today's day 9 of us solving data structure and algorithms. So in this case, we are going to keep two pointers, and we really don't care about the first position because that any element is anyways going to be the first occurrence, right? So we can start our first pointer 1, which we call generally L, as 1, and we can start our second pointer also from the same position. So we will start R also at 1. Now we are going to move first our right pointer ahead, and until it basically bounces out or becomes out of the bounds, we will continue iterating over the array. And as and when we encounter that we have discovered a position which is not equivalent to its previous element, which means it is actually a new element which we have encountered, we will swap. We will basically just replace that the left pointer with that element so that we get the new element. We don't care about what happens to the duplicate element because we are more interested in the new element. So here the swapping is not necessary. You just can move ahead the right pointer as well as the left pointer whenever you discover a new element. So if you see that it's quite similar to our previous element, there we were actually even interested in the first position because we were supposed to remove the values completely from the array. Here we are supposed to keep at least the one occurrence of each element in the array. So what is going to happen here is, now if you see at index position 1, I have 1 which is equal to the previous element. So basically I have not discovered in this iteration any new element. So my right is going to become 2. So right is incrementing now. Now at index position 2, I have discovered a new element because that is not equivalent to the previous element. Again, if I have not highlighted earlier, it's a sorted array, and that's why we are using a two-pointer technique because that's quite familiar with the sorted array problems, right, as a technique. So in this case, I have element 2 at index position 2 which is not equivalent to the previous element, which means I have now discovered a new element in the array, and that's the first occurrence of that element. So what we will do now is replace the position 1 with the position 2. So basically the output will somewhere look like this. So it will become 1 and this will become 2, and as we are not swapping, the right position still continues to remain 2. Now right increments and becomes 3, and of course right is now going out of the bound. So in this case, and left also increments because we now have to move, so left actually comes at this position, and right anyways is out of the bound, so we are done with the iteration. And in this case, left equal to 2 is what is our length of our new array. Now let's try to do it with with few more examples. Let's keep here 2 and then 3. So in this case, if we see, then ideally the length of the new array should be 3, right? So I should ideally get 3 as my position, right? So in this case, let's start again. Left is 1, right is 1. Now what will happen? This is equal, as we are moving first right, this is equal to the previous element, so we'll not do anything. So right increments and it becomes 2. Now this is not equal to its previous element, so we would like to swipe 1 and 2. So it will basically become 1, 2, 2, and of course 2 and 3 again, right? Now right becomes 3. Now at third index position, which is this, I have 2, which is, this is my new array, so which is equal to the previous element. So I'm not going to do anything with this, and right becomes 4. Now I have something which is, of course L also had incremented to 2 because we had swiped it. So now I have something which is a new element, so I am gonna replace this with the index position 2, which is this. So which means this will become 3, and left will increment and a right will also increment. Now in this case, a right has gone out of the bound, right? So we are basically with 3 elements as the output in the array. So if I print up to 3 as a position, it is going to be 1, 2 and 3, right? So this is what is the output of the array, right? So that is how we can solve this problem. And we are gonna do, in the next video, we are gonna do the another version of the similar problem, again with the same approach but with a twist. So if you get a hands-on two-pointer technique and you understand this technique quite well, you will be able to solve any array problem which actually is very similar to this pattern, right? So as you can see, two-pointer technique, we are able to solve remove elements, remove duplicates. Now we're also able to solve moving of the elements to the end of the array. So it's quite handy and it's quite easy if you just get the grip of this two-pointer technique. We will also solve some problems of linked lists with this technique, but we'll go through them in the coming videos. Now let's try to dive into the code of this particular problem. So here we are with the code of this particular problem. As you can see, the class name is remove duplicates, and as usual I have initialized it by expecting an array as an input, which I am calling nums, and I am returning an output called L, which is basically the length of my new array, expected length of my new array. So as you can see, we are just comparing with the previous element and trying to understand if it's a new element, and if it is a new element, we are swapping the left pointer with that, and we are incrementing left as well, and whatever is left at the end, that is going to be the expected length of our new array. So if you just correlate it with the dry run which we did, you will find that it is quite similar. So we had L here at the first position, we had R also here. When we compared R with the R minus 1, they are similar. So R gets incremented to 2 and left remains at the same position. Now R is not equal to R minus 1, so basically this step is going to be executed. So here 2 will come and L will come here, and R will go out of the bound, and we will left with 1 and 2 at the 0th and the first position, and 2 is going to be the length of our new array. So if we print this, I will just move to this directory and try to run this, and when we run this with Python command, so we have this file name as And okay, 1 minute, I think I've done some mistake here. So we have remove duplicates. Yeah, I have done a mistake of spelling mistake here, and then we run it, and as you can see, we are able to get the new array. We are able to get the array with the new length, which is 1 and 2, and the one which is the duplicate occurrence has been removed or has been moved to the end of the array, right? So that's how you are going to solve this particular problem. If you like this video, please smash the hit button, and also please subscribe so that you can learn along with me. Thank you. Happy learning.